So Karthik, we are letting the students in. Amit.
Yes, yes, sure.
Hello everyone, welcome to the fourth masterclass for the IBM Skills Build Summer Certification Program. We'll be starting this session very soon, but before that, I'm sure you guys know, make sure you have a good stable internet connection. All your friends and teammates have joined, and as always, if the Zoom gets full, this will be available on YouTube Live as well, and the link will be available on your WhatsApp. So you can watch that it from there as well. So we'll be starting with shortly. All right, let's begin. So, welcome everyone once again to the fourth masterclass of IBM Skills Build Summer Certification Program 2025. I really hope you all are excited and are ready for this session. So, let's start with taking a brief look at our timeline and also the key topic is that we are going to today. So we have gone through the orientation and the first three master classes. Today is the fourth class, and it is mainly about multi-agent systems. And before we could go forward, we will also take in some of your queries. But until then, please mark your attendance. You have the QR code in front of you. You can either scan that or you will receive the links in your groups as well as on the chat. So please take a few minutes and utilize this time to mark your attendance. And if you have marked your attendance, you can let us know in the chat by giving a thumbs up or saying a yes, and so that we can move forward. All right, let's take a few minutes. All right, let's move on. I hope you all have marked your attendance. So moving on, let's now talk about the most important topic that uh, we are facing a lot of queries with this. We are receiving a lot of queries, and even you guys are very interested and quite intrigued to get your domain IDs to register yourself on IBM Cloud. So, as we already mentioned, we are distributing your domain IDs batch by batch. So, very important announcements are that every person in your team will receive the IDs given that they have completed their assignments from the self-learning week. So if that has been done, then be assured that all those people will receive their domain IDs that they can use to register themselves on IBM Cloud. As well as we conducted a registration session yesterday, and I'm sure a lot of you were not able to attend because of your commitments. But the recording for that session explains all the steps starting from getting access to your domain ID all the way up to registering yourself on IBM Skills Build, and then going for getting your feature code, and then going forward and creating your IBM Cloud account. So please make sure once you guys have received your domain IDs, you can go through the recordings from the yesterday session. We have already shared the recording in your resource document. And also, what by now, all the leaders, I'm sure at least one person from each group has received their domain ID and password. And just to reiterate, everybody will receive their domain IDs eventually. But until then, you guys can work together as a team, use the domain ID to apply what you have learned and maybe learn even more whatever Mr. Amit will be teaching you and apply yourself. But eventually, all of you will get your individual domain IDs. And even more queries that you guys have about registering on IBM Cloud, for example, the cache query or the account deletion query, all those queries have been addressed in detail in the session that was held yesterday. And the recording for that session is uploaded in your resource document. So for any cloud related query, so the important announcement is that the leaders have received their domain IDs, and until everybody else receives, you guys can work as a team with that domain ID, and eventually everybody will get it. And for any questions or any queries or any doubts regarding domain ID in IBM Cloud. They have been addressed in the session that was held yesterday, and you'll find the recording in your resource document. So let's move on and welcome our speaker for today. We already know him, Mr. Amit Tiwari. Please join me to welcome him. So meeting is over to you, Amit. Please go ahead.
All right. Thank you so much, Karthik. Hello, everyone, and welcome back to IBM Skills Build program, certification program that you are going through. This is Masterclass 4 that we are having together. And today we are going to learn about large language models, understand the brain behind the agents and multi-agent systems. I'm sure that you all are designing your own agents and are learning along the way new things that is happening in the world right now. Today, what we are going to do is we are going to dive deep into and probe what are large language models, how do these work, and what we already have established this fact that these large language models are the brain of these agents that we have been designing so far. We have worked with APIs from Gemini, we have worked with ChatGPT when we were working with Relay, and we have been also working with LangGraph, LangChain, and a lot of new technology. Today, what we are going to do is we are going to have two parts of this session. First session is about the brain of agents and how can we design our own agents. And the second one is how can we design a multi-agent system where different types of agents are kind of like communicating with each other for different type of work that they have to do. All right, so let's start with what we will learn today. The part one explains how AI generates text and text generation. What are these large language models and how can we create one? What is the transformer architecture, which is kind of like the state of the art architecture behind designing these large language models, and how can we fine tune these large language models according to our needs? And the second part of this will explain these multi-agent systems, where we will introduce to the multi-agent system and how do they work, and we will design our own multi-agent system. Today, we are not going to use any of the difficult tools. We will be designing it very simply using drag and drop. But the core principles behind these multiple or multi-agent systems, how do they communicate? What are the type of files, and what are the push and pull mechanism that we need to make in all of these agents is what we will explore in the part two, where we will be designing our own multi-agent system. So I welcome you all to this extensive session. I think that a lot of theory part will cover what is happening in the world of generative AI, and the practical part will cover what is happening in the agentic AI realm. Let's dive deep into again the rules of the class. Similar rules that was there. I will have to use English language as a teaching medium because I teach students from all over the country, and even from non-Hindi speaking states. The difficulty of this class is designed for medium to hard level of tech understanding. Some of you might feel it easy, some of you might find it challenging to grasp. So ask questions in the chat box. You have been really wonderful in the previous sessions where you were asking questions about different concepts, and I was clearing that up. That also sets up the pace for the class. I have also some questions designed for you so that you have to also answer them in the chat box there. Participate. If you read, you will learn. If you hear and visualize, you will learn more. But if you participate, you learn the most. So participation is the key. And unless you have a memory chip installed in your brain, take notes, grab a notebook and a pen, because I believe that a lot of concepts that we discuss in this session, um, you will not be able to memorize or remember once you go back. All right, so what we will learn today about is text generation. Image generation is not what I'm going to cover because image generation is, I'm skipping image generation, maybe keeping it for the next session so that we can cover it up, because we also have to work on the agentic AI and the multi-agent systems. So I'll be covering how text is generated by ChatGPT and all the large language models. When I talk about large language model, I will talk about all the models. ChatGPT I'm using as a reference because a lot of us have worked in ChatGPT, right? And we also know it's one of the popular software that is there in the world right now. So I'll be using ChatGPT as a reference. But when I'm saying ChatGPT, I'm saying all the large language model, whether it is Gemini, whether it is Perplexity, whether it is Anthropic's Claude, whatever that you are using in your day-to-day life as a generation tool is what is a large language model. And I will just replace that with ChatGPT for easier understanding. In our last class, we were learning about prompt engineering, and we were writing these amazing prompts to train the chat GPT in order to generate certain amount of text. Today, we'll be working on that when we will be working on the agentic AI system. But before, how the ChatGPT is generating text and how text is being generated by ChatGPT is what we will explore in the first half of this session for the next 1 hour. All right, so the technology behind the generation of text by ChatGPT is prediction. All right, so if you go to ChatGPT and ask any, let's say, I go to ChatGPT and I ask any question to ChatGPT. If you see what ChatGPT actually is doing, so let's say, let me ask a question. What is the weather today? So if you see the answer that is being generated by ChatGPT is searching the web first of all, and it is giving me all this text, right? And this was not a very good example of how it should be. So I should ask it to write an article on agentic AI. All right, so if you see, it is writing all this article word by word, right? So it is just doing all of this word by word and not writing the whole article and then pasting it up here. So what actually ChatGPT is doing, or any large language model for that matter is doing, is what it does is generates the text by predicting the next word in the sequence or next token in the sequence. All right, so you give a prompt to ChatGPT or any large language model. What it does is it just predicts the next token that will come in the sequence of whatever words that we have given. We have seen this before. So when I was reading or when I was learning large language models back in 2014, it's been 10 years that I studied AI in college. When we were learning it, we were mostly learning about language modeling, and we were learning about these search engines and how to predict certain amount of text, right? So when you type something on Google, when you used to type something on Google back then, let's say that you type I want to, then it predicts the next words that you might type in the sequence, right? So I want to play games, I want to break free, I want to learn, I want to sell my phone, right? And also if you type something on your phone, let's say, please send me an, it predicts the next word that you might type, right? So it was auto correct or auto fill or auto predict. So email updated and update here in this case. So this was called language modeling. So you are writing something and the model or the software is predicting what you might type next. And this used to happen using count and search methods. So the Google will count how many times users are searching something. Let's say I want to and play. So Google will count how many times I want to play is being searched by people, and then it will do some probabilistic calculation and it will just predict how many times you have searched I want to play games, and it will give you a priority. So on the basis of whatever you might have searched in the past, if you type I want to, then cook can be the next word in the sequence, depending on how many times you have searched for cook, and then food will be the next word in the sequence. And subsequently for I want to play, there can be two choices, games and music, depending on how many times you have searched it before. I want to watch, depending on how many times you have searched before, movies and sports, depending on, because people don't generally search I want to work, so work will be given the least priority. And this is called language modeling, and this used to happen in 1990s and all. And yeah, no, it's so someone is asking more like a decision tree. No, it's not like a decision tree. It's more of like recommender systems. So like how Netflix recommends certain movies, right? So it's more of like if I type I want to, how many people are typing I want to cook? So I count that number divided by how many times people have typed I want to and something. So I will do a probabilistic calculation, and then based on a score of that probabilistic calculation, I will give the priority to the word which has been searched most by the people and which has been searched less. And then I make a decision on my own search history. Google will also store my search history, and it will also search how many times I have searched something. And on the basis of that calculation with my search history and the whole world search history, it is combining and giving it a ranking. Right, so language modeling used to happen it, and also it used to not just happen by search and count. There used to be many different type of techniques like n-gram models and all of these, where there is a large corpus on which we will train our language models on, and then we will also see how many words we want to see in the sentence, and then on the basis of the context we generate the next word in the sentence. And there were many technologies like LSTMs were there, RNNs were there, n-gram methods were there. So language modeling was already there. What all these new generative AI tools use, like ChatGPT, Gemini, Perplexity, and all the models that are there, they use something called large language models. And these large language models are the base of each of these generative AI tools. So let's learn it with example. So let's say that we want to answer the question which is there, where what is the tallest building in the world? And we ask this to any large language model. All right. So the first step that happens is because computer doesn't understand sentences, right? So what we do is we break these sentences into small pieces or chunks, which we call as tokens. And this tokenization is done before feeding these words to any large language model. Let's say ChatGPT, Gemini, or whatever large language model you are using. You will use this tokenizer. Each large language model has its own tokenizer, which chunks these words into different tokens. So here in this example, we are asking ChatGPT this question: what is the tallest building in the world? And it is chunking this what is the tallest building in the world as a sentence in 9 tokens. So these tokens can be words, these tokens can be symbols, these tokens can be sentences also, this token can be characters also. And it depends on what kind of tokenizer that you are using, right? So here in this case, if you go to platform.openai.com/tokenizer, you can check how your input is being chunked into different tokens by any large language model. So let's say that for the latest one, which is ChatGPT 4o and 4o mini, let me ask any question. Let's say I say, write an article on large language models. And if I press enter, then it shows that it is dividing this into 8 tokens, write an article on large language models. And this is very simple form of tokenization. Let me ask, Apple is a type of delicious, right? So for each language model that they are training, there is a different type of tokenization. So if you see ChatGPT 3.5 and 3.4, this tokenizes this as thus. And if I see ChatGPT 3 as a tokenizer, it also tokenizes it in 7 tokens. So previously, app was used to be as a separate token, and LE was a separate token. Now they have changed their tokenization method. So it depends on how your tokenizer is. So once I chunk the words into tokens like this, what I do is I send all of these words as in parallel to ChatGPT. Right now, I'm taking this large language model as black boxes. That means that I'm not explaining what is inside this. But later on, we will also explain what is inside these large language models and how it detects the next word in the sequence. Right? So if I feed this question as a prompt to a large language model, what is the tallest building in the world? And I ask it to predict or give me the answer. The tallest building in the world is Burj Khalifa, right? So now what it does is it just predicts the next and the next token in the sequence. So what is the tallest building in the world? It predicts the, right? Because the answers, they generally start with the. Then what it does is it puts this the as an input, and it predicts the next word in the token, which will be tallest, right? So now the input becomes what is the tallest building in the world, and it also includes this the as a token, and then it predicts tallest. And then it takes tallest into the input, and it will predict the next word in the sequence, which is building. Then it will take building into the input, and it will predict the next word in the sequence, which is in. Then it will take in the input, and it will predict the next word in the sequence, which is the. And then it takes the in the input, it predicts world. It takes world as an input, it predicts is. And then it predicts Burj, and then Khalifa, and then the end of sequence, because the whole sentence is being now predicted. So it also generates a end of sequence token, which tells ChatGPT that the answer has been uh, ended. So in English, it starts with it. It's kind of like a full stop. In other languages, it is different. So just by generating the next sequence token in the sequence, it is generating this whole sentence. And this is what the brain of a generative AI model is, and this is how it is working. It is not doing reasoning like humans, or it is not doing any kind of like processing like humans do, but it's kind of like a way of emulating how we generate language by just generating the next or predicting the next token in the sequence. But how does it predict? We are saying that, okay, ChatGPT is nothing but just a model which predicts the next token in the sequence. And by predicting the next token in the sequence, it is generating all these answers, right? So how does it predict, and what is the technology behind the prediction system is what we will explain now. So I already told you that all of these systems, the generative AI tools that we have right now, are basically large language model. That means that they are language models, but they have a large corpus on which they have been trained on. So what are these large language models? Let's kind of like dive deep into it and explain and explore how do these large language models work. All right. So basically, a large language model is just two files. And any company that designs a large language model, if you want to design a large language model, you will just need two files to be there. One is a parameter file, which is what you get after training these large neural networks on the data that we have. All right. So the initial ChatGPT 3.5 was this 175 billion parameter model, and it was around 800 GBs of data stored in this parameter file. And then we have a run.c file, which is kind of like approximately 500 to 1000 lines of code, which interact with these parameters and generate the text. All right. So basically what we do when we are designing a large language model is we take all of the text that is there on the internet. By all of the text, that we mean that all the filtered text that is there on the internet, basically the data that we have on Wikipedia, GitHub, social media, Pinterest, blog posts, and all of the data that we can get. We use these web crawlers to crawl the data from all around the web. And we call that data as corpus, and we run that corpus on this cloud or these GPUs. These GPUs have these neural networks, and a kind of like all of that data is compressed into these neural networks and these parameters, and then we can always talk to this in natural language. We will explain brief into it, how do we obtain these parameters, and what is the mechanism behind learning these parameters in the next section. So basically, these parameters, what are they? Are kind of like the weights and biases of a neural network. So you take a neural network, you take a big, vast neural network. So I have drawn this a very toy neural network here, which has three nodes as the input node. Then there are like 8 nodes as the hidden layer, 8 nodes as the hidden layer, and 2 output layers. But the parameters that are there here are just 122, because all these branches that are connected from one node to other, they have some weights that are associated to it, which fires the other node that is there in this whole neural network. So here the parameters are the number of parameters of 122. So imagine the scale of ChatGPT. It has 175 billion parameters there in the ChatGPT model. And this is kind of like a very large neural network that we train with all the text, all the filtered text that we have in the world. Now, how to train this? All right. So how do we train this big neural network on all the text that is there on the world? Is for a large language model, any large language model to design, these are the 4 things that we require. So we need a lot of data. We have already established that we need a lot of data called corpus, which we get by crawling all of the text that is there on the internet. And then we use something called transformer architecture, which I will explain in detail. On GPUs, basically these GPUs are very good in parallel processing, and we are feeding all of this data in parallel. And we pre-train these large language models. So basically from all the internet, all the data that is there on the internet, we train this language model to learn the language, and then we fine tune it according to how we want it to talk to us. All right, so I will explain all of these things in detail. The recipe to make a large language model, suppose if you want to make a chat GPT kind of like large language model, or any large language model for that matter, is just 3 steps. So you make a large corpus, you take a lot of data, you use web crawlers to crawl all of the internet, and then you make a really, really large corpus. Then you train the language model on that corpus, and then fine tune the model according to how you want it to behave. So step one is to build a corpus. And to build a corpus, what you use is you use web crawlers, and you use web crawlers to go to each of these sites. You go to Wikipedia, you go to Quora, social media, GitHub, Pinterest, articles, and blogs, and you filter out the content. You don't want it to go to sites where the relevant content is not there, maybe kind of like fake news websites or maybe fake content. You don't want to go there, but you want to go to credible sources. You take this credible source and you build a corpus by saving all the text that is there in the world. And then you train your large language model. But before we go ahead in our text, when we go for training, I just want to take a short poll from you in the chat box, and also take your questions there. The question is, how does ChatGPT generate text? And the questions and our options are A, B, C, and D. It generates paragraph by paragraph. It predicts the next and next word only in the sequence. It predicts the whole next sentence and displays it, or it generates the whole document at the same time. If you have an answer to this question right now, just reply with the answer number, and also why do you think that? So I'm getting a lot of answers from people. Thank you so much for replying. Thank you so much, Varun, Sanvi, Bhavishri, Vasundhara, Kriti, Pranav, and all. B is the right answer because it just predicts the next token. And I am really, really proud to see that all of you replying the right answer. All right. I'm also reading some of the questions that people have asked me. Divajali is asking, does this prediction work on how many users search most? Yes, what people, she's talking about language models, and you are absolutely right in the idea that it always works on the base of the prediction that people are making, right? Shriyanga Chaudhary is asking, can you explain the tokenizer part? So tokenizer, I will just go back a little bit. So what it does is basically whatever sentence that we have, whatever word we want to put into large language model, it chunks these words into smaller words. It chunks this sentence into smaller words or sentences, which we call as tokens. Why we need that is we can't feed the larger sentences sequentially because we are using this parallel architecture of GPUs, and these GPUs are really powerful CPUs which can process this text in parallel. So it's easier to chunk the sentence and then send it to the GPUs in order to make attention between two different words in the sequence. So when I talk about transformers, I will explain why do we do this tokenizing more and what is the significance of that. All right, thank you so much for answering, and thank you so much for interacting. Yeah, so Deep is saying it converts the tokens into vectors, then find the answers using it, then it chooses the most appropriate answer and data. Yeah, that's kind of like the gestalt of what a large language model actually is, but I will explain it in detail. Arush is asking the neural network part. So basically what we do is we take a large neural network, and we train this neural network on all the words that we have in the English dictionary. So whatever words that we have in the world, we take all of these words by using these web crawlers. We crawl through all of the world. We take all of the world, all of the text that is there on the world in a file, and then we train a neural network on whatever words that we have. And how do we train it is what I will explain now. All right, so the first step is to make a large corpus. Second is to train the large language model and fine tune the model. So we already have covered building a corpus, which is we take all the relevant text that is there in the world, not the text that is fake, or not the text that is kind of like not relevant. And then what we do is we train the model. And this training of the model is very, very simple. All right. So what we do is we take a neural network, just like the one that I showed. It was a toy neural network. But what we will do now is we will take a neural network which has kind of like billions and billions of parameters, and these parameters we will obtain by training the model. So how do we train this model? How do we train a neural network to predict the right kind of sentences or the right token that will come next is what we will discuss now. So what we do is we randomly cut any sentence from the training data. So let's say that I want the large language model to predict that the Taj Mahal is in Agra. All right. So this is kind of like my task right now, that I want whenever I ask ChatGPT or any large language model that I'm designing, if I ask where is Taj Mahal, then it gives me an answer that the Taj Mahal is in Agra. All right. So if I want to train that, I already know that Taj Mahal is in Agra, right? Because the text is there. So I take a Wikipedia page where somewhere it is written the Taj Mahal is on the right banks of River Yamuna in Agra. And what I do is I randomly cut this sentence from any place. All right. So if I wanted to predict that Taj Mahal is in Agra, I will randomly cut it from in. And I will ask a neural network, whatever neural network is there, to predict the sentence. Okay. And so let's say that here I cut it from here and I ask it to predict this Agra. So what it will do is this neural network, it will adjust its weights and biases, and it can predict anything that is there in the initial stages. Right now I'm training this neural network, knows nothing about Taj Mahal. This neural network knows nothing about Yamuna. So whatever information it has prior or no information at all, it will generate some of the text, right? Let's say that it predicted Delhi as example. And Delhi is a wrong answer, right? Because Taj Mahal is in Agra and I know that, right? I know it from my training data. So what this neural network will do is it will adjust its weights and biases. So it will adjust the value that is stored in these nodes and these branches up to uh, up to a level where it predicts Agra. All right. So what I will do is I'm making it, I'm explaining it in very, very simple, intuitive kind of like understanding here. So what I will do is I will calculate the probability of these words and I will compare it with the original sentence. So let's say that it predicted Delhi and I compare it with the original sentence that, okay, the answer should be Agra, not Delhi. And I subtract the error that is there. I will find out the error and I will back propagate that error into the large language model, right? So let's say that it predicted Delhi with 90% accuracy and not Agra. I subtract the error. I fed that error back into this large language model or this neural network. It adjusts its weights and biases up to a point where all these weights and biases give the output as Agra. All right. And what I will do now is I will do the similar thing for every text that is there in the world. All right. So I randomly cut after the, and I ask it to predict the next word, right? And I know the next word is Taj, or maybe whatever the next word is there in English language, and it will learn that after these kind of words come. So it will learn the language that after the, maybe some noun comes after the, right? So generally it will also learn the patterns that is there in the language. And what we will do is we will train these large language models on a big cluster of these GPUs. So ChatGPT was trained on 60,000 GPUs, ran for almost 30 days continuously, taking in a lot of electricity, taking in a lot of carbon, also emitting a lot of carbon dioxide in the process. But the output of that was we obtained those 175 billion parameters. That is the value that is stored in all these nodes and weights and branches. And this model, this foundation model, is what a large language model is. Now, how do we train this? We are saying that, okay, we are obtaining these parameters, and we are also saying that, okay, we are predicting the next word in the sequence. How does it happen? Is through transformers. All right. So if you have heard anywhere about transformers, or if you are into artificial intelligence, you might have, I'm 100% sure that you have heard about transformer and the architecture. But even if you're not, if you see the full form of GPT in ChatGPT, so GPT says generative pre-trained transformer. So it has three parts. Generative means that it generates something, which is text or image. Pre-trained, that means that we train it previously with whatever text that we have on the planet. And transformer is the architecture that we need to train this large language model. All right. So if you have heard about transformers, and if you are talking about these kind of transformers, no, I'm not talking about these transformers. And even if you have heard about transformers and you're thinking about these transformers, this is not also not the transformer that I'm talking about. I'm talking about transformers which look like this. This is kind of like a software architecture through which we make these large language models understand the language. So in 2017, a research paper was published by Google's Deep Labs. And what they did was the research paper was named as "Attention is All You Need," and they were like two Google Brain. Sorry, the Google Brain was the branch, and there were two Indians also in that research, Ashish Vaswani sir and Nikki Parmar ma'am. And what they did is they said that, okay, in order to train this computer with language, we need a different kind of like software architecture, which looks like this. If we follow all of these layers, then we will be able to train the computer to understand language. The transform has two parts. One is the encoder part and one is the decoder part. The encoder part of it and the decoder part combined together is used to do translation purposes, but only the decoder part of it is used for generation purposes. And this is what we will require or we will study in today's lecture, the decoder part of it and not the encoder part of it, because we are mainly interested in generation part of large language models and not the translation part. All right. So very easily, I will explain this transform architecture in a very, very simple and intuitive language. I'm not going to go into hardcore mathematics and all to explain this. So how to make computers understand language is what our objective is with transformer or large language models. And this is kind of like a programming architecture, which you can see as a 5-story building. All right. So the first story building is the input embedding or the output embedding for a decoder part. And then there is positional encoding. And then there is this masked multi-head attention layer. And then there is a feed forward layer. There is a linear layer and there is a softmax layer. All right. So 1, 2, 3, 4, 5. There is a 5-story building. So the word enters from the first floor and it goes out from the last floor. All right. So look at it as this. It's just for the intuitive part of it. So we already said that, okay, if we want to predict the next word in this sequence, right? So let's say we take an example of apples are a type of delicious, and we want to predict what comes next. So if I want to predict what comes next, first is what I need to do is I need to do tokenization. So I divide these words into different chunks, divide this sentence into chunks called tokens. And I feed all of these tokens parallelly to this first layer of my software architecture, which we call as transformers, which is the word embeddings. All right. So what are these word embeddings? Basically, these word embeddings are how computer understand language, right? So computer doesn't understand words, right? So computer can only understand numbers. So computers doesn't understand what apples are. Computer doesn't understand what delicious mean. Computer doesn't understand what type is, right? So if I talk about the word that is what we have here, right? So how can we make computers understand these words? All right. So what we do is I have a simple quiz or a question for you. If you can predict what will come next. All right. So if I say king minus man and I add woman to it, what will be the answer to this equation? Right. So if you can just predict, Akashdeep is saying queen, Nandini is saying queen, Sargun is saying queen. All right. Janvi is saying queen. Devansh is saying king woman, which, okay, yeah, king woman is not the right answer. Queen is the right answer. So how were we able to add and subtract words? All right, so this is very interesting. So we cannot add and subtract words, right? We can only add and subtract numbers. So, but we can do this, right? King minus man plus woman. So king minus man is some position. And if I add woman to that position, then I get queen, right? So if I subtract man from the king and then add a woman to it, then I will get a queen as the answer. And this interesting part of adding and subtracting words is what makes this architecture really interesting, that we can treat words as not as words, but we can treat them as vectors. All right, so similarly, if I do certain things like this, like India minus Delhi, and I add Paris to it, this will become France, right? So India minus Delhi plus Islamabad is Pakistan. India minus Delhi plus Dhaka is Bangladesh. India minus Delhi plus Beijing is China. So how can I add and subtract words where I can only add and subtract numbers, right? So this understanding of taking words as numbers is what changed the whole way that we look at language in computers. And we want words to not just be represented by numbers, but also they need to have certain direction called vectors. All right. So these were if I make this very simple, I cannot draw a 300 dimensional vector, but I can only draw it in 2D. So the basic understanding is the words which are similar. So queen and king are similar. They will lie in a same direction in this hyperdimensional vector plane, and words which are different, they will lie in different direction in this hyperdimensional vector plane. And just by calculating the distance between two words and by using simple vector calculus, we will be able to represent these words as vectors. And if I subtract king man to this and I add a woman, it will give me this queen vector, which is already there um, in in this domain. All right. So we can treat words as not as numbers, but also as vectors, which have a direction and a kind of like magnitude. To get these vectors, there are different kind of techniques. One technique is one hot vector, where we give um, each word a different vector. So let's say that if I want to encode abacus, what I will do is I will put 0 in all the places and only 1 in the place of abacus, and keep 0 in all the other places. All right. So by this, by the position of this word in the English dictionary, I will just put a 1 in its position, and all the other things are 0. So this is very basic way of designing these words as one hot vectors. There is one more method called word count, how many times one word has occurred in a document. So let's say that Aaron has occurred 4 times in a document. I will give 4 to Aaron and 0 to all the other. How many times? This is also called that kind of like the word frequency. And also there is one more way of encoding or these or obtaining these word embeddings, which is by co-occurrence, where we calculate how many times each word is occurring with the other word. All right. And then there is one more way on which we obtain these word embeddings is by training a neural network on the words, and then it understands what words come after and what words come before a word, and what is the contextual understanding of a word in a sentence. And then it gives value to these to each of the word, and these values are 300 values, which is the most common one, which we called as the word to vec algorithm, which is a 300 dimensional vector in which there are 300 values for each word, and these values are learned by the large corpus trained on a big neural network. So that let's not go into too much deep there. So the basic idea behind word embedding is to find out which two words have more similarity in English language. And this similarity can be found by calculating the distance between two words. It can be a Euclidean distance or a Manhattan distance, or it can be also the cosine or sine similarity between two words. So two vectors which are in the same direction, they will have a similarity because their dot product will not be 0 if you have learned math anywhere in your at any point in your life. And the two vectors which don't have any similarity, like mango and snowflake, they will be 90 degrees to each other. That means that they are orthogonal, and their dot product will be 0. So, by calculating this Euclidean distance and sine and cosine similarity, we will be able to find out which vectors lie in a common direction, and these vectors will have more similarity. And by understanding these similarities, we can get the dictionary meaning of each and every word. And the second, after making this word embedding, after making all these words as vectors, basically these words as numbers or a long string of numbers, which have now the understanding of what the word is, some meaning of these words in this long string of vectors, what we do is we go to the second layer, which is called positional encoding. So positional encoding is why we need to do this, because English language is any language for that matter is very syntactic. That means that the way we write a language defines how it means. So let's say I write dog eat bones, which makes sense. But if I change the position of the words and make it bones eat dogs, that won't make any sense in the English language. However, it is grammatically correct, right? So if I change the position of words, then I break any sentence into a nonsensical sentence. So it really matters how we are assigning this position to each word. So because we are feeding all these words in parallel, we need to assign the position to the words in a very simple way. In a very simple way, I'm understanding that all these words are given these numbers 1, 2, 3, 4, 5, 6, and 7 based on the how the position of these words are there in the sequence. But in reality, what we do is we kind of like take a vector of sinusoidal waves, and these sinusoidal waves are then being multiplied with these word embeddings, and then these are added to find the position. It's kind of like a complicated process, but in the idea of positional encoding is to make these words to give each word a position in the sentence so that we know where each word is, because we are feeding it in parallel and not by sequence, right? After making the words having the word embedding and the positional encoding, we add this. So we add word embedding and the positional encoding together, and then we now have the idea of what a dictionary meaning of a word is, and also what is the position of that word in the sequence or in the sentence, right? In the input sentence. We go to another layer called masked multi-head attention. This is where the magic happens, or this is where the prediction actually happens. This is where the understanding part of the sentence happens, all right? And then it goes to a feed-forward network. So what is attention mechanism? So in English language, the dictionary meaning and contextual meaning of words in a sentence are different, right? So if I mean something somewhere in English language, then it doesn't consistently mean the same. So the meaning of a word in a sentence changes according to the context, right? So in order to explain it, I have these two examples. So the first sentence is the elephant could not fit in a car because it was too big, right? So if I ask you to tell me the meaning of it here, okay, so what does it mean in this sentence, right? Can you tell me in the chat, what does it mean in the sentence? Elephant, right? So it can mean it is the English word that is used to represent to a non-living thing and also a living thing, right? So in this case, there are two things, elephant also, and there is a car also. So it can mean elephant, it can mean car also, but because it is used in this sentence, the elephant could not fit in the car because it was too big. It is now pointing to elephant. Okay, so Honey is saying car, which is absurd. And because car is not big, right? So if I look at big here in the sentence, it will always point to elephant, right? If I change the meaning of sentence to this, now if I change the last word in the sentence, small, how now where will be the it pointing to? So if I say the elephant could not fit in the car because it was too small, I just changed big to small, right? So I just changed from big to small, and the meaning of it changes, right? So now it points to car, right? So now it points to car because I am paying attention to small, right? So this understanding of the words, that they don't just have a dictionary meaning, it can mean elephant and car both, because in English language, it can mean a living thing and also an animal. But when I use it in a sentence, how do I use it depends on what the meaning of that word will become, right? So in this case, it points to elephant, and in this case, it points to car. So this is what was dealt with the attention mechanism. And in the paper, if you read research papers, attention is all you need. Then what the Google researchers say that what we need to do is we need to pay attention to certain words in the sentence in order to determine what is the meaning of that word. So if it pays attention to elephant and car and small, then the meaning of it will become car because it is paying attention to small. All right. So in this sentence, if I pay attention to elephant, car, and big, then it will mean that elephant is where it should point to in this sentence. And based on that, it will predict the next word in the sequence, or it will predict, it can understand the sentence or the query better, right? Because now each word is paying attention to different words. So in this layer, the attention layer, what we do is, although it is really complicated what we do in attention layer, but in order to explain it very, very simply, what we do is we change all of these word embedding. So we made these words as vectors. We make this 300 dimensional vector, and then we also add a position to all of these vectors. Now what we will do is we divide all these word vectors into three vectors: query, key, and value vectors. So these query, key, and value vectors are again obtained by training these vectors with neural networks, and a query vector is obtained by training the word embeddings and positional encoding with a neural networks which already has some weights, and these weights are then added to form the query vector. The query vector of each word multiplies with the key vector of each word to find a value of each word. And what we will do is the query vector of apple will multiply with apple, the key vector of apple. The query vector of apple will multiply with key vector of r. Query vector of apple will multiply with the key vector of a. Query of apple will multiply with the key vector of type, and this will happen. And the value of the vector, whatever after multiplication of query and key vector, a value vector is obtained. And based on this value, we know which words I need to pay attention to in order to predict the next word in the sequence. So if I talk about here, apples are a type of delicious, then I need to pay attention to apples, I need to pay attention to type, and I need to pay attention to delicious. So these three words, if I pay attention to apples, type, and delicious, I will be able to predict the next word in the sequence, which is fruit, right? All right, so the next layer is a feed-forward layer. We are here, so I'm going a little bit fast, but feel free to ask questions. I'll be able to answer these questions once we complete the first part, all right, which is the large language model part. So this mass multivariate attention, after attaining this query, key, and value vector and finding out which words do we need to pay attention to in order to predict the next word in the sequence, we feed them into a feed-forward layer in order to implement some non-linearity. All right. So why do we need to implement non-linearity? Is because linear systems are not robust. Non-linear systems are better in prediction. So we implement a non-linearity. We use a very simple function called rectilinear function, which we call as ReLU. And thus a non-linearity is imparted. And from a feed-forward network, what we do is we go to a linear transformation network where the next word in the sequence, so we have apples are a type of delicious, the next word in the sequence is generated, and it is mapped with all the words that are there in the English language. And a score is being given. So there are all the words, Aardvark to Zulu, and each word will have some probability of occurring after this, right? So apples are a type of delicious something, but this something is out of all the words that are there in the English language. So all these words basically tokens. So fruit is one possibility because apples are a type of fruit. Laptop is one possibility because apples is also a company that makes laptops. Snacks is also one possibility because apples, some people take them as snacks. But the score will be depending on how many times my corpus has seen apples as fruits, and the understanding of apples as fruits is and then paying attention to apples, type, and delicious, then I will be able to say that the next word in this token is fruit, right? So if I go to ChatGPT and if I ask ChatGPT this question, apples are a type of delicious, then you will see that it will always say fruit. And if I say apple is a type of, then it says fruit, and apple is a type of technology, and it can say that it is both referring to fruit and technology company depending on the context. And in the technology context, it is a multi-technology company, right? So it is depending on what words it is paying attention to, uh, uh, the sentence or the kind of text that it is generating. So if I pay attention to delicious, type, and apples, then always the fruit will have um, more score. And then what we do in the last layer is we kind of like softmax it from 0 to 1. And all these scores are now ranked not on a random number like this, where there was some score. This score is normalized up to 1, and a probability is calculated on the next word. And then obviously with this score, the probability can be given as fruit is with 92% probability, snack as 8% probability, and laptops maybe somewhere around 1% of probability, right? So this transform architecture, after this transform architecture, what we will do is we will get the probability of the words that might come next, with the highest probability of the word being the one that is chosen, right? All right, I will skip the quiz time because we are already late. We also have to design these multi-agent systems. But before going into multi-agent systems, there is one more step left in the large language model. So we have a huge corpus. We trained it on neural networks. We try to find these parameters in which we store some values based on, we train it with transform architecture. We kind of like make understanding between the words. We pay attention to certain words in the sequence, and we know the meaning of the sentence, and then we predict the next word in the token, and then we map it up with all the words that are there in the English dictionary. We choose the word which has the highest probability of occurring, and that word is generated, right? So once we train a model, that is called a foundation model. So all of these models which are trained, they are called foundation models. And then you tune this foundation model in order to behave like you want it to behave. Like GitHub has tuned its Copilot model to more code. So it has trained this model on more code, as well as it has fine-tuned it to generate code. So GitHub's Copilot doesn't generate any other thing than code, right? So it only generates code, and also it gives you some more understanding, but it is not very good in talking to you like human. ChatGPT, in other part, it can also generate code, but it is also very good in talking to you like another human, right? So after making a large language model, what we do is we need to do fine tuning. So these fine tunings can be done by different ways. One very common way is by human feedback. That means that RLHF, reinforcement learning through human feedback. This involves a model that has been trained to be tested with human in the loop. So ChatGPT, what it did is it employed 30,000 plus people in order to fine tune its model. So it gave the responses to all of these people and says that, okay, ChatGPT is generating this. Now make it humanize and give it back to ChatGPT that this should be the answer. And ChatGPT learns from the answer from a human, and it tries to generate the similar kind of text. If you see ChatGPT, you will also see these things for fine tuning, where you can always tell if it's a good response or if it's a bad response. And this also trains the ChatGPT to always give the right responses. And if it's not a right response, then give it a bad, and it says it ignores that response in the next time. There are many different methods for fine tuning. There is also data set fine tuning, which a lot of companies use. What they do is they take a foundation model from any of the companies which have trained the foundation model. They use their own data set in order to train that foundation model to also gain information which it doesn't know. Right. So let's say that I have a hospital which has different type of queries coming, and ChatGPT doesn't know about my hospital, right? Because I only know what the data that I use in my hospital. So what I will use is I use this data to train this large language model in order to fine tune it for my own particular use case. And then there is transfer learning. There is few shot learning, which we learned in our last masterclass, the prompt engineering thing, that we gave few examples in order to make this foundation model learn from the examples, and um, uh, then learn and then write in a similar way, where we trained it to name like iPhone, iPad, and all these things, and it was giving me all those names with I only. So that's kind of like few shot learning, where you give few examples in the prompt to make it learn from this. And prompt engineering obviously is crafting effective prompts that guide the model in generating the desired output. So you use all of these techniques in order to fine tune your model. And once a model is fine tuned, we get uh, uh, a model which we call as a large language model or a generative model, which different companies have named differently. All right. So before I move ahead into my section 2, which is where we are going to design multi-agent systems, I have some questions in my chat, which now I will answer. If you have any question new that is coming in your mind, then ask. So Zoel James is saying that does every model need run.c file? I don't see such file in local chatbot model. So basically what this run file is how you interact with the model, right? So basically you have these parameters which you store in these big GPUs, and you interact with these parameters with a run file. It can be in any language for that matter, right? It can be in C, it can be in Python. So what you are seeing in any large language model is you are seeing a UI. So this UI is being generated by, let's say, Java, right? So when you send something to this UI, it makes an API call, right? So this API call is basically, it goes to the system. Whatever prompt that you are giving, the prompt goes to the system, and this run file sends this prompt to the large language model, and the large language model returns with a response, and then it sends it back to you, right? So this run.c file is not such file in kind of like local chatbot models. Basically, it's kind of like a file in through which you will interact with a large language model. It can be in any language for that matter, right? So you have these parameters, and you also have a run file which interacts with this parameter. You can't just interact with this parameter directly, right? So you need a file where you are doing all this processing. Maybe you are doing tokenizing before you are feeding it to the parameters, and then you are getting the answers from these parameters. And you only need to get these parameters once. So you need this transformer architecture only once. Once you obtain these parameters, then you don't need it, because these parameters will do the rest of the task for you. Thank you for this amazing question that you asked. I also have some more questions. Shreya is saying, I hear you using the neural network and LLM interchangeably, but I guess LLM is only one kind of neural network. Can you explain what's the difference between two? What others neural network? All right, so basically large language model, I'm not interchanging large language model and neural network. I'm really sure about that. I'm interchanging large language model and ChatGPT for sure. So basically large language model is basically a neural network only. So you can't use it interchangeably. So basically large language model is when we are designing a large language model, we are basically training a huge neural network in order to obtain these weights and biases, in order to basically compress all the language that we have in the world into these weights and biases in order to talk to this neural network. It knows how a language works. It knows the features of a language, and then by writing a run file, you can interact with these parameters and then can generate the results. Final project I will guide tomorrow. So tomorrow will be the class about the final project, what you need to design and all. They have any platform or tool to train it, like for handling big data using Apache for real-time data handling and etc. All right, so basically there is no platform to train large language models. You have to like create these large language models by investing a lot into this GPUs, and then on these GPUs you will design this transformer architecture on which you will train on all the data that is there in the world. So it takes a lot of effort, and that's why India doesn't have any large language model, right? Because it needs a lot of resources, it needs a lot of tech storage as well as compute power in order to train these large language models. But to fine tune it, of course, you can take any foundation model and then fine tune it according to your own preferences by hyper tuning these QLoRa and LoRa parameters, right? So basically they are a low range optimization parameters that you fine tune in order to obtain your own large language model. But I'm asking for the final project. Final project I will explain tomorrow. So why optimizers are used? So basically what we need to do is on whatever hardware that we have, we need to kind of like optimize these parameters in order to get the desired result. So let's say that there is also one thing called temperature, which we already have used in our last class, right? So temperature is also one parameter. So lower temperature will mean always the kind of like high reliable results. That means that same result each and each time. And higher temperature means that large language model will become more creative. So basically, we need to optimize a large language model in order to uh, get a desired result. So let's say that I'm fine tuning my large language model on a file, and that file doesn't have that much of data that it will be able to create a whole new large language model altogether. So I need to find a kind of like a sweet spot where my large language model is not hallucinating and giving any other answer. It is reading my file in order to whatever data that I have in order to learn from that and then write the answer. So we need to optimize certain parameters in order to get that sweet spot of not hallucinating and providing the right answers. Role of large language model. So role of large language model is that it is the finest artificial intelligence tech that we have in the world right now. All the things that you see, all the generative AI tools that you see, even image generation is happening through large language models. ChatGPT, Gemini, or any other tech that you name it are all large language model, and that's how the role of large language model in our agentic AI. These large language models form the brain of the agentic AI system that we are designing. All right, so let's move ahead in our Dhanvi is asking, sir, my question is about small language model. Do they need less training or is it derived from the large language model? So basically, how can I test the limits of a training a model on my laptop, NVIDIA GTU? All right. So Dhanvi is asking what is a small language model? So basically, small language model is kind of like a distilled version of a large language model. So you take a large language model and you train less parameters. So you take a less parameterized neural network and you train a less parameterized model on this large language model because you already have obtained these parameters and you don't need to you know how to write the correct results, and you don't need to you need to filter out a lot of garbage that is there in a large language model, because in these parameters we can store a lot of text. For a small language parameter model, we need to take a corpus and we need to train this small language parameter, and also we need to optimize this small language model with a large language model in order to distill the information to a very low level. So if you use something called Olama, you will be able to use a small language model, like let's say uh, a llama 2 billion parameter model or a 7 billion parameter model in your NVIDIA GPU very, very easily. And DeepSeek's 1.2 billion parameter model is also very good. But the answers that a large language model with more parameter will give uh, will be more reasoning based, will be better than a small language model, because it's a very distilled version of a large language model, right? And it is also said that the data that you train your model with depends on how good your model is. So if you train your large language model with more code, then it is very good in reasoning. If you train a large language model with educational content, then it is very good in hypothesis generation. And if you train it on entertainment, it is very bad. So basically, there is a priority on which we need to train our large language model in order to make them how we want to be made. How much time does it cost us to create the whole AI chat GPT type of thing? And how does company bear this cost? Right. So basically, they get funding. ChatGPT got its funding from Microsoft to develop. It got $100 million funding for designing its own AI systems, training the 4.0 model, even the 3.5 model. So it needs huge GPUs. So one GPU costs around 1 million rupees, $1 million. So basically kind of like 6.7, 65. Now the cost has come less. Now I think the highest one that NVIDIA has, I think it comes around 65 lakhs or 64 lakhs or something. And we need kind of like 60,000 of that. So you can just multiply 60,000 into 64 lakhs into 60,000 and then calculate the cost. So it costs a lot. And also it takes up a lot of energy. And that's why India is not designing a large language model, particularly right now. But maybe in the future when we don't need, so large language model is only one way that computers understand language. There can be many different models, like China did with DeepSeek when it introduced this reinforcement learning with large language model in order to train them on a very low resources, right? So there is a big gap still that we need a lot of resources to train large language model. Maybe in the future we will design some algorithm which is very efficient. We will be able to do it with a very less compute power. All right, so let's move into multi-agent systems. This is what we are designing, and this is what we were talking about. And how can we collaborate? How can we design collaborative AI system So we will take our example of what we designed, the intelligent hospital management system. But what we designed was kind of like a single agent system where one agent was doing all the work. Today we will talk about multi-agent system and multi-agent collaboration and how can we achieve that, right? So the agenda is to introduce to multi-agent systems and to hospital agent system case study. How does one agent communicate with other and coordinate, and hands-on implementation of the same. All right, so what are multi-agent systems? So till now, what we have designed are single agent system where one agent is only working, right? So we designed a hospital agent system where the receptionist agent was doing a classification of the task of the disease into general, emergency, or medical or mental health, and then it was guiding into those different type of fields, and it was doing something. So every task was being done by single agent, right? So in a multi-agent system, we design multiple agents which will do different type of tasks, and they share a shared environment in order to achieve individual or collective goal. Right. So these all these agents, they operate independently without direct human control, and each agent can operate from different type of outputs or inputs also. So let's say that a receptionist agent gives some instruction to this general ward agent, and this general ward agent does some work, let's say maybe calling a doctor or maybe emailing a doctor. But that general ward agent can also be called by some other agent and not particularly the receptionist agent. So it can also act independently out of the system also, right? They also have a social ability. That means that agents can communicate and coordinate with each other agent. They also are react. They also have reactivity. That means that they can respond to environmental change in real time, and they also are proactive. That means that they take initiative to achieve their objectives. All right. So how to design these kind of like multi-agent systems is what we will talk about today. So the architecture components that a multi-agent system has is it has an agent layer. So individual AI agents have individual agent layers. So each agent that is there in a multi-agent system, they have their own architecture, they have their own knowledge base, they have their own decision-making algorithms, and they maintain their own state and goals. All right. And then there is a communication layer, which is a message passing protocol. How will we pass a message from one agent to other agent in order to share information, coordinate some action, negotiate the solutions. And then there is an environment layer where all these agents will operate, shared workspace. And then there is a coordination layer where if there is a conflict between different agents, how will we um, make that go away, right? So we will not be talking into more about each one of this, but we will be taking a example through which we can learn everything. All right. So this is a hospital multi-agent system where we have these four agents. Let's say that we have a receptionist in a hospital. So we will design a receptionist agent, which will with the first layer or maybe one of the layer of this hospital system, which will take in the patient, and it will intelligently classify this into whatever ward it wants to send it to. Then there will be a general ward agent where patients' routine care and standard medical procedures are there. There is an emergency ward agent where critical care is needed to be done. There is a mental health agent where psychological support and psychiatric care is there. All right. So now a patient in our previous system where there was a single agent system, the patient had to go from receptionist agent, right? Patient had to go from receptionist agent, it had to go from receptionist to any of these wards, and then it was being taken care of. Let's say that if I skip this there, if I don't go to the receptionist, I directly go to the general ward, then what will happen, right? Then how will be the processing be is what a multi-agent system also can facilitate, right? So all of these agents are now independent. There is a receptionist agent, there is a general ward agent, there is a mental health agent, there is an emergency ward agent, and all of these agents will be orchestrating together. They will be working together with each other in order to make a whole hospital agent system. All right. I will explain each of these agents. So the receptionist agent is a system gateway. So basically, you will have this kiosk screen in the hospital where you can deploy this agent. So this agent will take in the patient and does the symptom analysis, right? So it uses NLP to extract key medical indicator, whether the patient is suffering from a general disease, whether the patient is suffering from an emergency condition, or whether the patient is needed to be sent to a mental health ward, right? So it also analyzes the symptom, it also does the classification, and it also does the routing. It also sends the patient to appropriate ward agents. All right. So let's say that we imagine a system where everything is being done by robots and there are no humans involved in hospitals or these systems. Then the first agent, the first robot that we interact with is a receptionist whom you give the information. It already knows what kind of disease that you are struggling with or suffering with, and it sends you to the particular agent. So it's kind of a decision tree where emergency keyword trigger immediate routing, mental health indicators route to specialized care, and all other default go to the general ward. Okay. Then we will design this specialized ward agent. So we will design an emergency ward agent where if there is any trigger like chest pain, difficulty in breathing, severe injury, loss of consciousness, then this will be triggered and this will respond to uh, immediate triage protocol, resource allocation for critical care, or whatever we want to do in the emergency ward agent. In a mental health agent, if the triggers will be depression, anxiety, suicidal ideation, behavioral concept, and then mental health agent will take care of that. General ward agent will do these general routine checkup, minor illness, and follow-up appointment and everything. All right. Now, how will the communication will be? The patient will submit a form, and that form will be analyzed and classified, and then it will be selected. Agent will be selected on the base of the classification, and that agent will work on its own. Okay, so not to be delayed with the theory, I will do the practical right now. Please try to just learn it. If you do it with me, then we will be blocking the resources and you will not be able to design the agent, or maybe I will also not be able to design the agent. So just learn how I'm doing it right now and then implement it later. Okay. So I'll be using Relay app. Although you can use anything, you can also use LangGraphs, which we learned in the last time. You also had a session of RAG, so you can also implement RAG. Lot of you have not got the IBM IDs. That's why I'm not using IBM's Orchestrate, but the process is similar. So if you understand one agent, one type of system, you'll be able to design it in any architecture if you want to. So you can design it in N8N, you can design it in Zapier, you can design it in IBM Orchestrate, you can design it in LangGraphs. Right. So anything you can design it, but the only thing that you need to understand is the core concepts that are involved. All right. So let me design a UI for it first. Okay. So for my agent, let me design a UI. So I am designing the receptionist. Okay. So I go to a Google form. And I will design a Google form to take the input. Okay. And what I will do is I will name this form as receptionist agent. Okay. So I create a new form, which is a blank form. And I name this as receptionist. Okay. So this is my UI. Okay, so I'm using free tools because I don't want to go into Node or React or JS and all in order to design this. This will also take a longer time. So I'm using a form here as a Google form. Okay, you can design this form in any way. So let's say that you want to design it for a kiosk screen, you will design it in JavaScript, or you can design it in HTML, CSS, JS, or whatever technology you are comfortable with. The only idea is that it should parse on the responses. Okay, so the first question is name of the patient. Okay, so I'm saying that what is the name of the patient, and I am asking a short answer for the name of patient. And the next thing is age of patient. Age of patient, and that can be a short answer. And also I can do a validation that the number is between 1 and 100. Otherwise say input valid, invalid. Okay, so let's say that I am only taking in patients from 1 year to 100 years, and that can be the age of patient. And we can also ask for what are the symptoms. Okay, so I am basically designing It can be a long answer text or a short answer text, depending on how you want to receptionist agent. Okay, how you want to take the responses, and that's it. I am right now taking all these three. Maybe I can create a bigger or better form. That can be your project also. You can create a bigger or better form where you can have drop downs. You can also ask for nationality. You can also ask for phone number, email ID, and all these things. Maybe I can also ask for email ID here so that we can also email the patient. Email ID, and it can be a short answer, and it is required. It is also required. What are the symptoms is also required, and name of patient is also required. Right. So basically, I'm creating a UI for my agent, and I publish this, and I publish this here. All right. So now I'm taking the form in this UI manner. All right. So now I have this receptionist agent and agent form. So what I will do is I will go to relay and I will create this receptionist agent. Okay, so relay.app. I can do it with LangGraphs, I can do it with anything, but basically what you need to do is understand how we are going to design this. All right. So I'll go to login to this relay app. And don't worry, I will explain it one more time. We'll go through everything together and make this agent, but just learn it once so that it is not, the servers are not going down. Okay, so because many of us are joined in at the same time, so servers might go down if we all work together. So I design a receptionist agent. Okay, so I call this agent as receptionist agent. And because it's a multi-agent system, so a receptionist agent will be there, which will classify whatever type of disease is there, and then it will send it to particular agent based on what kind of care that patient needs, right? So I will add in a trigger here. So this trigger basically triggers this agent, how the agent is being triggered. So how I will do is if a form is submitted, so once a form is submitted, anyone submits this Google form, this agent gets triggered. Okay, and this form that I want to select is receptionist agent form. Okay, and I say done to it. Okay, so I take in information from this receptionist agent form and I add in an AI. Okay, so I add in an AI for classifying, or maybe a custom prompt. Okay, so you are an experienced. Now I will use my chat, prompt engineering here. You are an experienced receptionist in a hospital. Okay, based on the customer query or problem, which you take from, I will press an @ and you take it from symptoms. Okay, query or problem or symptoms. Okay, classify the symptoms into one of the following category. Okay, now I'm being specific. So first principle was to give it a persona. So I gave a persona. Second was to be specific. I am getting specific or give direction that I want to classify symptoms into one of the following category. What are the categories? One is general, when the problem is general and don't need any expensive or special care. Problems like fever, cough, etc. Okay, and I say emergency when the problems are critical and need immediate help. Okay, don't worry right now, not to like you are not doing it with myself, but we will be doing it in the next 10 minutes. Okay, once I make these agents, just look at it once and then you will be able to understand it better, because then we will not spend much time in designing these agents. Okay, so general, emergency, and then there can be mental health when the problem is related to mental health, like depression or other mental health related issues. Okay. So I say that whenever a person comes, take this query, you are a very expert receptionist. And also now I need to specify the format, right? So return the answer in one word only. From general, emergency, and mental. Okay, so return only general, one word, general, emergency, comma, mental. Okay, so just return general, emergency, or mental, depending on whatever the uh, the category is. Okay, and I say done. All right, so I used my form as my UI to get the response. The response goes to a large language model, which makes a decision whether it should classify it as general, emergency, or mental. And then what I will do is I will use a flow control. Okay, so I will use a router kind of thing. So in a router in a relay kind of setting is a flow control. So I will make a path and I will set rules. So rule 1 is if the AI output symptom category is general. Okay, so if it is general, what to do? Else, I will add one more. Else if the AI output symptom category is emergency, or if symptom category is mental. Okay, now I will define what to do in this. Okay, so I will define now a general ward agent, a emergency ward agent, a mental ward agent. Okay, so I also named them general ward, and I name it emergency ward, and I name this path C as mental health ward. Okay, so in a multi-agent, in a single agent system, what I will do is I will define all the steps here. Okay, so I will define steps ki general ward mein hai to kya karenge, emergency ward hai to what we will do, and for a mental health ward what we will do. Okay, but in this multi-agent system, what we will do is we will go back to relay and I will create another agent, which I will call as a new workflow. So I will create another agent and I will call this agent as my general ward agent. Okay, so this is a general ward agent and it will be triggered by a webhook. All right, so the communication channel between these two agents will be a webhook. It will be a request that this agent will generate here, and this agent will take that webhook request, and whenever that webhook is called, so this when the problem is general, then this agent will call a webhook which goes to this agent, which calls this agent. Okay, so I will have to copy this unique URL for this webhook from here. So I copy this unique URL for this webhook request, and I add a step here in this agent, which is a general word agent, as a webhook. Okay, so I add a custom HTTPS request and I paste the webhook of the other agent. So the other agents, basically other agents link I will paste here. Okay, so I will go to make a other agent which will be triggered when a webhook is called, right? The webhook will be a communication channel between one agent to other agent. and I copy the URL from this webhook here and I paste it here. All right. And the method that I will use is a post method. Okay. So I'm sending some data from here, this agent to this agent in order to process. Right. So what data I will send? I will send a JSON file. So the very basic type of data that we send or a very reliable type of data that we send is a JSON file. So we will send a JSON file. And this JSON file, what we will do is we will configure this manually. Okay, so we make a JSON object in which we will send this data. Okay, so whatever data I want to send from this agent, in order for this agent to work, I will send it in a JSON file. And this JSON file will have a property of the data that we want to send. Okay, so let's say that we want to send the name, okay, patient name. And the value of that name will come from the form response name of patient. Okay, so first data that I am sending is the name of the patient. I am also sending another data, which is age, and I take that from age of patient and I save that. Okay, so I'm sending the name, age, and also I'm sending the email address. Okay, email, and I'm taking that email from email ID. All right, do I need to send the symptoms? Maybe or maybe not, depending on whether you want that in the next this, but I don't want to send the symptoms to the next one. I want the symptoms only to classify it from to general emergency or um, general emergency or mental health. Okay, so I'm taking this symptom. I'm not parsing this symptom. I'm only sending these things: name, age, and email. Okay, I'm sending this to the other agent, and I'm saying done here. Okay, now my first agent is completed. So I get a form response. My ChatGPT classifies it into general, emergency, and other mental health, and my webhook is being called upon. So if my symptom is general, then this webhook will call this general agent, which I designed here. Okay, which I will now design. Okay, so this general agent will get data from post, and I will have to configure its input manually. So its input is actually a JSON object. In this JSON object, I need to specify what I will get. I get name, I get text as age, I get text as this email. Okay, I need to keep these three and these three as same. Okay, name, age, email, which I am sending and which I am receiving, name, age, email. So this is basically a protocol that I am designing. Okay, so I am receiving these three things from this agent. Receptionist agent will send these three things, name, age, and email, to my general ward agent in order to do something, what needs to be done. Okay, so now I will add a step, what needs to be done in a general agent. Okay, so let's say that we have a doctor and we want to email a doctor. If we get a let's say we have, like, let's say two doctors. Okay, one is a children's doctor and one is a doctor of uh, age more. So what we will do is we will use a flow control, and whenever a patient goes to a general ward, then it can go to two wards. One is a children ward and it can go to a adult ward. Okay, path B is adult ward. And we also need to specify rules, right? So this webhook calls the data that we get or receive from another agent is called a payload. So this payload is age, and this age is all right. I think I should have specified this as a number, right? So this should be a number. Okay, so this age should be a number, and I say done. And if now I remove this from here and I add a rule that age is less than, let's say, 18. Okay, so if age is less than 18, then children ward doctor will be called, and if age is greater than 18, right? So if age is greater than or equal to 18, then I will call another doctor. Okay, so let me just design a system to call doctor. Let's say that we use email as a method right now. We can use anything. Let's say we can also use WhatsApp. We can also use, I think WhatsApp can be used using Twilio here, but I'm not using WhatsApp. It's a kind of like complicated process right now. So I will use Gmail for for simplicity. So basically you send an email and send an email to email address. Let me take my email address 2503@gmail.com. Okay, so let's say it mails to my personal email when a pediatrician or a children doctor is needed. Okay, subject is patient uh, patient needed. Okay. You can just say you have got a new patient for general inquiry. Okay, and body mein you can say that hello doctor, we have a patient named, and you take that name from the webhook call, right? So you get this name from the name, what your receptionist will send you. We have patient name named for general inquiry. Please reply with a uh, please reply with a time and date to give this person to person as a appointment. Okay, you can also make this email written by AI, but we don't want to do that right now because we want AI to only make decisions and not these things like these general purpose emails, right? And regards, and we can say that general word. Okay, so this is what we did. And similarly, you can, if the age is greater than or equal to 18, then what happens is that we send an email to another person. Let's say that my other ID, which is amit.t@csrbox.org, and subject is new adult patient. We can say, hi doctor, you have got a new adult patient, name, and you can also say age, but right now that's not needed. So you go to name and you say regards, or you can say please schedule an appointment, and then you can say regards and your name. Yeah, sorry, general ward agent. Okay. All right. So you designed a multi-agent system where for each of what this agent does is it sends an email to the doctor, and it also can wait. Now it also can wait for the email. So it can also read the email from the doctor, extract whatever time and date the doctor has given, schedule it in a calendar. It can also send this email, right? That's whatever email that it receives. So it can also read the email. So can read email. Email. Yeah, you can also wait for reply, but you can also write emails from here. Yeah, maybe we can just instead of like sending an email, we can also wait for the response. And as soon as the response is got, you can also send the same information to the patient, right? So maybe instead of this, I'll just copy it. Maybe you can send email and wait for reply. All right. So you send email and wait for reply, and you send this email to whatever person that you want to. But that's kind of like mm, right. So I'm not doing this right now. Just that you can make when you want to make your own project, right? So let's do this. Let's try this. Okay. So I will just make it on and done. And I'm saying that okay. I'll just turn this on. The issues are there is nothing defined in else. I'll delete that part. And not all are properly configured. It is properly configured. 18, I think 19 because it already said 18. So I think I will have to add 18. All right. Now it is fine. Okay. And I turn on this agent. So I'm turning on my general war agent, and I'm also turning on my receptionist agent. Right. So now is the time to test it. So I'll just quickly test it once, and then we will all design our own agent together. All right. So I have published this receptionist, and I want to test it. So I will test it by getting a link from here. And yeah, so it's restricted. Response view is from my group. Right now I have keeping it from my group because I want to make this form only reply from certain account. All right. So let's say the name of the patient. I want to fill this. I will fill this form, and then let's say that I'm a patient. I'm here, and I'm Zamit Tiwari, and my email ID is let's say Amit dot Tiwari at the rate sxa dot edu dot in, and my age is 32, and my symptom is that I have fever. Okay, and I submitted. So this is the user interface. All right, and I submitted this form, and it says that my response has been submitted. Now I will go to my relay app and see if my trigger is there, right? So it runs one time. So basically, as soon as I submitted the form, it ran and it gave me a trigger. And in the relay app, I see that it also run one time. That means that my apps are working nice. Fine. Now I will go to, because my age was 32, it went to adult ward and it sent an email to my CSR box ID, the other doctor, the doctor of the adults, and I'll go to my Gmail and see if I have got the mail. And voila, I have got a mail, new adult patient. Hi doctor, you have got a new adult patient. Patient name is Amit Tiwari. Please schedule an appointment. Regards, general ward agent. So general ward agent is working amazingly, right? So it is now sending me these emails, and it also is understanding whether or not I am adult or not. So it is sending me to my adult doctor, right now. And let me do it one more time. So with the receptionist agent, I am submitting another response. Let's say I submit a response for a child, and let's say the child's name is Harshit, and email ID is harshit at the rate gmail.com, and age of the patient is, let's say, 14. Okay, and the symptom says that I have cough. Okay, and I submit this. And once I submit this response, my relay app will run, and it ran one more time. It is running, and it will also show me. It will automatically run. I did nothing, right? So it ran and it goes to general ward. And after going to general ward, it also ran here after calling the webhook. And second ran one goes to children ward, right? So it automatically knows that the age is less than 32, so it went sent to a children ward. And now I will not get my mail to this doctor who is an adult doctor. So I will not get a mail here. What I will get is a mail to a pediatrician, which I have configured my email address as this. All right, so this is the last step, and then we will design it. Yeah, so you have got a patient for general inquiry. Hello, doctor. We have got a patient named Harshit for general inquiry, and I'm getting it in my other email ID, which I configured for my. Yeah, so we have got a patient, Harshit, for general inquiry. Please reply with the time and date to give to this person as an appointment. Regard, general ward agent. All right, so I have designed multi-agents now. Now one agent is not doing all this work. So there are two different agents, and then I can design other agents as well. All right, so now let's do it step by step. So the first step to design this agent is to design a form, a Google form. All right, so to design a Google form, go to forms and go to click the link of the forms there, Google Forms, sign into your Google Forms, and then create a Google form. All right. So once you create it, send done to my to the chat box if you have created the Google form. All right. So the Google form that you have to create is of a receptionist agent, which will be serving as your UI. Yeah, so Amit is saying, what if I can tell ChatGPT to do all this process? Yes, you can tell ChatGPT to do all this process, but will it create a Google form? I doubt. But you can take cursor and can make a UI part of a form where it takes in this data in a form, but you need to be very sure what type of data that you are collecting. All right. So right now what we are going to do is we are going to create a Google form, all of us together, of a receptionist agent. So we will type in the name of agent, email ID, age of patient, what are the symptoms. And once you are done, send it in the chat box as done. All right. So now you have known the steps. Maybe you will be able to do it faster, but I will check it here one more time by seeing your responses as done. All right, so go to Google Form and create a new Google Form, name it as receptionist agent, and then put in the steps here as name of patient, email ID, age of patient, what are the symptoms, and then we will design our own agent, which we'll call as receptionist agent. While you will be designing your receptionist agent, I will be designing the emergency ward agent as example, and then we will see the whole process as together. Right. So first, create the form. Once you are done, say done or yes in the chat box, so that I know we are all in the right track. All right, so still waiting for people to design the form. Okay, I've not got a single yes or done from anyone. Maybe it's taking some time, waiting for some more time in order to you to design the form. once you design the form, we will design our first agent in Relay app, which we'll call as the receptionist agent, which is a multi-agent system. Got it from Abdul, Mohammad Abdul. Nishant is also done with the form. Still waiting for more people. Yana is done with the form. All right. So once you're done with the form, Aman is done, Pushkar is done. Thank you so much for replying, because that will help me set the pace for this class, because then only I will know whether to go to the next step or not. All right, so once you have designed the form for the receptionist agent, basically this will act as a UI to your agent. So your patients will come in, they will interact with this form, they will fill in their name, they will fill in their email ID, they will fill in their name and what are the symptoms that they are having. And once you get this form, you go to the Relay app. So you go to relay.app and you create your first workflow, which will be a receptionist agent, right? So how to create this workflow is you go to your Relay app, which I think you have logged in the first class, and then you just click on new workflow, and that new workflow will be of a receptionist agent. I will just show you how the workflow looks like. So a receptionist agent will take in your form as an input. So it will trigger whenever a form is being submitted, right? So once you submit a form, it will be triggered, and then it goes to ChatGPT. So you take in first, the second step is to use a AI. With AI, what you do is you use a prompt engineering. So you tell the AI that you are an experienced receptionist in a hospital, and based on a customer query, whatever query that they are having, and you take this query from the form response that they are submitting and classify the symptoms into one of the following category: general, when the problem is general and don't need any extensive or special care. Problems like fever, cough, and all should be sent to the general ward. Emergency, when the problems are critical and need immediate help. Mental health, when the problem is related to mental health, like this depression or other mental health related issue. And you also specify the format in which it should answer. It should answer in one word: general, emergency, and mental. All right, and then you use a flow control in order to design it like a if and else statement. So if general ward, then go to this general ward agent. If emergency ward, then go to emergency ward agent. If um, mental health ward, then go to mental health ward agent, right? And what you can also do in your final project, what you can do is you can also create a very nice UI using HTML, CSS, JS. You can use ChatGPT to create this beautiful AI UI for you. And then you can use that form information as a JSON to parse on to the Relay app using the webhooks, like I did, right, with this. So the trigger then again will be a webhook, but this webhook you will trigger from this URL in your UI that you have, right? So if you are creating a website, so this website will create a webhook in which you will enter this webhook. This is the webhook, and you will parse on a JSON file, which will take the payload of name, age, and email. And that JSON file will parse on to this webhook. And this webhook is called whenever this some after you click on submit on your form, this webhook will be called, and this information will be processed. So email will be sent, and you can also send a response back to your UI that an email is sent. So I can't display it here with the Google form and all, but with a webhook, you can definitely do that. But if you want to create it with Relay, you are more than welcome. You can also create it with Relay. So let's now create a receptionist agent, which does this. Any new form is submitted. So you click on input trigger. Trigger is when a form is submitted, the form should be receptionist agent from your email ID. And when that form is submitted, you take it to a large language model like ChatGPT, which kind of like divides this form response into what are the symptoms and classifies into general, emergency, and mental health, and then return in one word: general, emergency, and mental. And then you take these three different kind of situations where each agent, now you design each agent for a general word. What happens if a person has a fever or um, a cough, then you send it to uh, a relevant person. So if you also want to design something like a pediatrician and adult doctor, then you can also, here in the general ward agent, you can define with logic that if a person is less than 18 years of age, then you will send an email to a pediatrician, and if it is more than 18 years of age, then you can send it to an adult agent, right? So, and then you make a decision on the base of that. And then you can make different agents, and then you use webhooks to call these agents. All right. So the agent that now I am making is another agent, which I will call as the emergency ward agent. Okay. So I have created a general ward agent, and I will call a emergency ward agent. And how will we design it? Is the trigger will be a webhook. Okay. And this webhook, I will copy it from here. So this is very important. Okay. So if you want to like kind of pause the video when you are doing it on YouTube, then you can always pause it here. So you copy it here, and where my receptionist agent is. So my receptionist agent is here. And in the emergency ward, I will add a step, which will be a HTTP request, which will be a custom HTTP request. And I paste this webhook here. All right. And I will use a post method in this webhook to call this webhook, and I send a JSON file which will have again these values. So I send a JSON object here, and I have the property of this object as string, and the name I'm sending is 3, name, and name I get from this form name. And I'm not sending age, because no matter what the person is, I'm assuming that the emergency condition is for everyone, and maybe we can add in name. Maybe we can add in name. Sorry, age. Okay, so age, I take it from age of patient. Okay, and I save it. And yeah, and I also send as string. Property is symptom, and it says symptoms. Okay, so I'm name, age, and symptoms, and I'm sending it to my emergency ward agent. And now I'm creating this emergency ward agent. So this emergency ward agent, what it will do is it will just call a Google Sheet. Okay, so it can call a Google Sheet, and it can make a direct entry of the patient. So it is not sending an email. If it is emergency, then we are taking this patient directly into the hospital. We are not sending email to the or any appointment, right? So if it is a critical condition, then I can use this Google Sheet, and I can add a row to a sheet. My sheet can be, let's say I will create a Google Sheet, and inside this sheet, I'm signing in, and I can create a Google Sheet which takes in this patient entry. Okay, so I am directly making this patient enter the hospital system by creating a patient entry sheet. Okay, and I'm saying here name and age, problem, and situation. Okay, and name. Okay, so what I will do in this emergency agent is, what I will do is I will add a row to patient entry, and in sheet 1, I will insert at top of the sheet, I will insert name, and this name I will take from webhook call. Here also I need to take input, right? So I need to take input as a JSON object, and this field will be a text field, which will be name. And I also get a number, which is age. I also get a text, which is symptoms, and yeah, done. And this sheet, I will populate this name from the payload, which is name, right? I add one more field, which is age, and I populate this age from my payload, which is age. And I add one more field, which is problem and situation. Yeah, name, age, problem, and situation. Okay, so problem will take in the webhook call payload symptoms, and situation I will add text as critical. Okay, I say that situation is critical. I'm not adding it from anywhere. I am saying that critical situation is there. All right, that's all. This agent will only fill a Excel sheet where a patient is having a emergency condition. All right, so let me check it once. So I go to my receptionist agent, I submit another response. I say that my name is any random name Priya, and I have my email ID as priya@gmail.com, and the age is 30, let's say 30. Symptoms are that I had a huge accident where there is um, blood running down from my forehead. Uh, uh, the patient has lost consciousness. Okay, so I submit this, and it goes to this relay app, and it runs one more time, and it goes to another relay app. So emergency ward agent, and let me check whether it is working properly or not. So I refreshed it, and okay, so run 3 went to emergency ward. There are no steps in this path. I think I did not save it, publish it, right? So I needed to publish it, and yeah, so now it's published. Okay, so I think I need to publish this also. This is already published. That's why I did not run. And yeah, I published it, and I will just give it a test run. I will submit one more form. So let's say we submit it for another one. Let's say for Rahul, email ID is rahul@gmail.com, and age is 32. Symptoms is the patient has a heart attack. Okay, and let's just submit it. So let's see if it is working properly or not. And I go to relay app, and it says that it is giving me a run, and here also there is one run. So it knows that a heart attack is an emergency situation, and it goes to this agent called emergency ward agent. And if I see my sheet, I have everything there, right? So I have Rahul, whose age is 32. Problem is not mentioned here, but the situation is critical. So I have directly made Rahul an entry in my hospital, right? So it will save a lot of time for Rahul in order to not get a appointment from doctor, and it is already taking care of that person. All right, so that's it. That's how you can create all these different agents and then make them work together using webhooks. Make sure that you are creating these webhooks properly. You are parsing this information in a JSON format. You're getting this information in a JSON format from the other agent, and you are then using this information in order to do certain works in the agents that are there. All right, so that's all from my side. Thank you so much for being so patient, and hopefully that tomorrow is the class where I will explain the project that you have to make, and hopefully you all make something which is relevant and very useful for the humanity, just like we designed a a hospital agent where patient's life can be saved on the base of what disease that we have, right? So that we can prioritize them, and we don't need a receptionist in order to and it can work for like 24/7. It can also work on holidays. A receptionist has its own limitations, right? So that's all from my side for today. Thank you so much for being so patient till now. If you have any questions, any doubts, any queries, I will solve it in tomorrow's class, not today. So tomorrow we will not have a longer session. So we will have a shorter session of 1 hour where I will explain the project, and then I will take on your queries, whatever you have. Thank you so much for asking beautiful, beautiful questions, which I have saved in my chat box, which I will use tomorrow to answer. So uh, some people are asking that can I slow down the procedure so that you are able to do that? I think I am I was not that fast enough in order for you to understand it. Not understand it. If you are not able to understand it, go to the YouTube link, and then you will be able to, I think, rewatch the video, design this agent, and uh, yeah, process it. Right. So tomorrow is the last day of our class, and we will be able to finalize the project. And yeah, so we'll be able to finalize the project and then design a project. So I'll be telling you what are the problem statements in this. I'll be taking your questions tomorrow. So now we can end this. The team can now float the out attendance for this class so that all of you can mark your out attendance, and then probably can complete it from the YouTube. All right. Thanks a lot, guys. We'll be meeting tomorrow for the class.
Thank you. Thank you very much, Amit. It was a great session. So, hello everyone. I hope you also enjoyed this session from Mr. Amit. So let's get back. We'll quickly end this. But before we go end it, few quick announcements. So starting with a very important masterclass tomorrow. It's quite obviously, Amit has repeatedly mentioned that it is the last class, but it is also important because tomorrow Mr. Amit will tell you more about your final project, what you have to do, what you have to achieve as a group. So keep this in mind that the class tomorrow is very important. Maybe inform your friends and teammates, other people as well, who might not be able were not able to attend the session today due to some commitments, but they make sure that they are there tomorrow, as it is our final masterclass and a very important one. So moving on, again reiterating and repeating the announcements that every single one of you who have completed the self-learning week assignments, you will be receiving a domain and ID password and ID domain ID pass and I password soon. So do not worry if you haven't received them. So by now we have tried to make sure that every team gets one, but I see we are still receiving queries that some of the teams have not received, but do not worry about that. We are dispatching the domain IDs and passwords batch by batch. You all will be receiving them very soon. All right, so that was it for today. I really hope you had a great learning experience. Hopefully, the multi agent systems were quite intriguing and interesting for all of you. It was surely for me. So, we will be closing this here. The attendance out QR is on your screen. You will receive the links in your chat as well as your groups. Please make sure you mark your attendance. So, thank you everyone very much, and I'll see you all tomorrow.